Hello and welcome to HP Gaming Garage. I am Professor Raja Ravichandra Prasad, Game Director at Artemisia College of Art and Design. The ninth module of Game Programming is Game Engine Unity Part 3. This module is a continuation of Module 8 and I would highly recommend watching the previous module before proceeding with this one. In this module, we will be exploring more features of Unity that will enable a game developer to create versatile and engaging games. Over to you, Shreyams.
Thank you, Professor. Hello everyone, I am Shreyams and we will be discussing the module Game Engine Unity Part 3 curated by Professor Raja. Let's start by discussing more another interesting feature of Unity, collision and rigid bodies. Unity's collision system provides a dynamic and realistic way for objects in a game or simulation to interact with each other. By adding rigid bodies to game objects, one can create a world that responds to physics-based forces such as collisions, gravity, and external forces. These components allow objects to move and behave as if they are affected by the laws of physics, adding a layer of realism to your game. The physics engine in Unity handles the calculation of forces and interactions between rigid bodies, making it easy to create objects that react realistically to collisions. With this system, you can create complex simulations and realistic gameplay mechanics. Here are some key concepts related to collision and rigid bodies in Unity. Colliders are essential components in Unity game development to define the physical shape of game objects for the purpose of collision detection. Unity provides a variety of collider types such as box collider, sphere collider, capsule collider, and mesh collider, among others, each suited for different shapes and purposes. By attaching a collider component to game objects, developers can create realistic physics simulations and interactions between game objects. For objects with simple shapes such as walls or platforms, the box collider is an ideal choice. Meanwhile, the sphere collider is perfect for objects with rounded shapes like balls or orbs. The capsule collider is a popular choice for objects with cylindrical or humanoid shapes, like characters or poles. The mesh collider provides accurate collision detection for complex or irregular shapes, but it can be more computationally expensive. The terrain collider is designed specifically for terrain objects, while the wheel collider is perfect for simulating vehicle wheels. For character movement, the character controller provides built-in functionality for handling movement, gravity, and collisions. The cloth collider is specifically designed for simulating cloth physics such as clothing, flags, or curtains. With these options available, developers can create compelling games with realistic physics-based interactions. Adding a rigid body component to your game object in Unity can unlock a whole new level of physics-based movement and collision detection. With rigid body, your game object can be affected by various physics forces such as gravity and external collisions with other objects. The rigid body component offers a wide range of possibilities for your game development needs, including the ability to simulate realistic physics-based interactions between objects in a game or simulation. In Unity, there are three different types of rigid bodies: dynamic, kinematic, and static. The dynamic rigid body is the standard rigid body component that provides realistic physics-based movement and collision detection for objects like characters, vehicles, and props. With kinematic rigid bodies, one can precisely control the movement and rotation of objects manually through scripts making them ideal for animated characters and objects that need to follow specific paths or animations. The static rigid body component is perfect for objects that should not move or interact with physics simulations such as terrain, walls, or other immovable objects in the scene. It is important to choose the appropriate type of rigid body for each object in your scene based on its intended behavior and physics requirements. Using the correct type of rigid body can help you achieve the desired physics-based interactions and movement for your objects in Unity. In Unity, collision detection is a crucial aspect of creating realistic and engaging games. With its advanced collision detection methods, Unity enables developers to accurately detect when two objects with colliders collide. The two main types of collision detection in Unity are discrete and continuous, offering different advantages and are suited to different scenarios. Discrete collision detection is less computationally expensive and can detect collisions at discrete time steps, while continuous collision detection is capable of detecting collisions between fast-moving objects and those that intersect with each other at high velocities. In Unity, collision response is a powerful feature that allows for realistic physics-based interactions between objects and rigid bodies. When two objects collide, Unity automatically calculates the resulting forces and interactions based on the physics properties of objects such as their mass, velocity, and collision properties. This means that one can create realistic and engaging gameplay experiences where objects bounce, slide, and roll just like they would in the real world. In Unity, the developer can add more depth and excitement to your game by implementing custom logic for handling collisions using collision event callbacks like onCollisionEnter, onCollisionStay, and onCollisionExit. With these callbacks, one can detect and respond to collisions between objects in the game, update score points, play sounds, or trigger game events. By using these events, one can add a variety of custom logic to the game to enhance its realism and interactivity. onCollisionEnter is particularly useful for detecting the moment of collision and performing actions that create an immersive gaming experience, such as playing a sound or spawning particles. This event can help to make the gameplay dynamic and exciting. onCollisionStay is a great tool for detecting continuous collisions and updating actions in real time. This event can be used to apply damage or physics forces while the collision is ongoing. Finally, onCollisionExit is perfect for detecting when objects separate after a collision and performing actions that end collision-related effects or revert changes. These events can be easily implemented as methods in the scripts, allow one to detect and respond to collisions in real time during gameplay. Other than these, we also have onTriggerEnter, onTriggerStay, and onTriggerExit callbacks to detect and respond to collisions with trigger colliders. These events are specifically designed for trigger colliders, which are colliders that don't generate physics responses, but instead trigger events when other objects may enter, stay, or exit their boundaries. The onTriggerEnter event is triggered when an object enters the trigger collider, making it perfect for detecting an object when it enters a specific area and performs actions such as triggering events, changing game states, or activating game mechanics. onTriggerStay event is triggered when an object stays within the trigger collider, which can be used for detecting the continuous presence of an object within the trigger area and updating actions like checking for ongoing conditions or applying persistent effects. On-trigger exit event is triggered when an object exits the trigger collider, which is typically used for detecting when an object leaves a specific area and performs actions such as ending trigger events, reverting changes, or deactivating game mechanics. So, if you're looking to add some interactivity to your game, be sure to take advantage of on-trigger enter, on-trigger stay, and on-trigger exit. With Unity's layer system and collision matrix, the developer has the power to precisely control the interaction between objects in your game. By assigning objects to different layers and configuring the collision matrix, you can create complex collision scenarios that enhance the gameplay experience. Let's recap collision and rigid bodies. In Unity, colliders are components that can be attached to game objects to define their physical shape for collision detection. A rigid body is a Unity component used to simulate physics-based movement and collision detection. There are three types of rigid bodies: dynamic rigid body, kinematic rigid body, and static rigid body. Dynamic rigid bodies respond to gravity and other physics forces. Kinematic rigid bodies are not affected by physics forces like gravity or collisions, but can still apply forces and move or rotate manually through scripts. Static rigid bodies are fixed in place and not affected by any physics forces, collisions, or movements. Unity uses two types of collision detection: discrete collision detection and continuous collision detection. Discrete collision detection detects collisions at discrete time steps and is less computationally expensive, while continuous collision detection detects collisions between objects that are moving quickly or intersecting with each other at high velocities. When two objects with rigid bodies collide, Unity calculates the resulting forces and interactions based on the physics properties of objects such as their mass, velocity, and collision properties. Unity provides collision event callbacks to detect and respond to collisions between objects in a game. On collision enter, on collision stay, and on collision exit are used for detecting collisions between objects with colliders, and on trigger enter, on trigger stay, and on trigger exit for detecting collisions with trigger colliders. In Unity, objects can be assigned to different layers and a collision matrix can be configured to determine which layers can collide with each other. This provides control over which objects can interact with each other, enabling the creation of intricate collision scenarios. Now let's discuss the next topic of the module, raycasting. Raycasting is an incredibly powerful technique that can enhance the interactivity and realism of your Unity game. By detecting collisions or intersections between a ray and objects in the scene, one can create dynamic and engaging mechanics such as object picking, shooting, and physics-based interactions. With its versatility and ease of implementation, raycasting is a must-have tool for any Unity developer looking to take their game to the next level. By creating a ray with a starting point, direction, and length using the ray or raycast hit class, one can easily cast it to another scene using physics.t raycast or physics.raycastAll method. This will provide valuable information about the first object hit by the ray or all objects hit by the ray, including the collided object, the point of collision, the normal of the collision surface, and other useful data. Raycasting is a versatile technique that can be used for a wide range of purposes, from object picking and shooting mechanics to physics-based interaction and line of sight detection. By casting rays from various sources such as the player's weapon or camera, one can detect collisions and interactions between objects, creating realistic physics-based responses such as jumping or falling. You can also use raycasting to check for obstacles or terrain height, generate a navigation mesh, or calculate a path for AI agents or characters. The possibilities are endless when it comes to custom physics and interactions with raycasting, allowing you to simulate complex collision detection and unique interaction between objects. Let's have a look at the recap on raycasting. Raycasting is a technique used to detect collisions or intersections between a ray and objects in a scene. It can be used for various purposes such as object picking, shooting mechanics, physics-based interactions, line of sight detection, navigation and pathfinding, and custom physics and interactions. By creating a ray with a starting point, direction, and length using the ray or raycast hit class, one can easily cast it to other scenes using physics.traycast or physics.raycastAll method. This will provide valuable information about the first object hit by the ray or all objects hit by the ray, including the collided object, the point of collision, the normal of the collision surface, and other useful data. Let's move on to discuss input basics. By taking advantage of Unity's built-in input system, developers can easily and quickly create compelling, immersive gameplay experiences for players by allowing them to take control of their game with a variety of devices. Here are some of the basics of Unity's input system. The Input Manager in Unity is an invaluable tool for developers, providing them with the ability to customize input access according to the specific needs of their project. With the Input Manager, developers can map keyboard, mouse, and gamepad inputs, ensuring that their project has the utmost precision and flexibility. Unity's input access are essential components that allow players to utilize their own movements and rotations. By mapping these input access, such as horizontal and vertical, players can create a unique and personalized experience. The input.get button function is used to detect when a button is being held down. For example, input.get button jump will return true as long as the jump button is being held down. The input.get button down function is used to detect when a button is pressed down. For example, input.get button down jump will only return true on the frame when the jump button is first pressed down. The input.get button up function is used to detect when a button is released. For example, input.get button up jump will only return true on the frame when the jump button is released. This property returns the current position of the mouse cursor on the screen. This can be used to track mouse's position and perform actions based on its location. Let's take a look at the recap on input system. In Unity game development, an input refers to any action that the player takes through a device such as keyboard, mouse, or gamepad. Unity provides a built-in input system that allows developers to easily handle various types of input. The Input Manager is a built-in feature in Unity that allows developers to define custom input access which can be mapped at various input devices such as keyboard, mouse, or gamepad. Input access are named input variables that Unity provides such as horizontal and vertical, which can be mapped to a player's movement or rotation. The input.get button function is used to detect when a button is being held down. The input.get button down function is used to detect when a button is being pressed down. The input.get button up function is used to detect when a button is released. The input.mouse position property returns the current position of the mouse cursor on the screen. This can be used to track the mouse position and perform actions based on its location.
Thank you, Shriyams. With this, we have come to the end of the 9th module and I hope you enjoyed it. Stay tuned for your HP learning assessment so that you can be certified and start your career in game development. Thank you for joining us.